In today's lesson, we're going to face the interesting problem of figuring out whether two triangles are congruent. Now, just a reminder, to be congruent, the two triangles have to have three sides of exactly the same length, in exactly the same order, with the same angles as well. Now, we're going to find out, which is kind of interesting, that you don't need a whole lot of information to make a very conclusive statement that they are, in fact, congruent. You actually just need three pieces of information, as long as those three pieces of information are the correct pieces of information. Now, we're going to use a lot of acronyms today, such as this one down below. So if you see SAS, what it means is side, angle, side. And these have to be in order. So as you can see on triangles ABC and DEF, we have markings that show that side BC is congruent to EF, side AC is congruent to DF, and angle C is congruent to angle F. We would say that this is side, angle, side because we're going in order. I usually like to start with either the angle marking or the side marking that has the fewest stripes. So here BC has one. Next, C is labeled. So that's side, angle, and then here we have another side in order. And then you can look for the same things, the corresponding markings on the other triangle, and make sure that they are in the same order. So we've got single marking, angle, double marking. And since we have all of these three pieces are congruent, we can say that these two triangles are congruent, and we would say that the reason is the side angle side theorem. There are a number of these that will make a triangle congruent, and there are a few that will not make a triangle necessarily congruent. So here's a list. I would recommend writing this someplace that you can access very frequently as we go back and forth to this list throughout the unit. If you have all three sides of the triangle are congruent, a side, an angle, and a side, like we just saw, an angle, a side, an angle, or angle, angle, and then a side. These four will make any two triangles congruent. If you have a right triangle, we have a special case where if you know the hypotenuse, which is the side across from the right angle, and one of the legs is congruent, this is one that will also work. Now, there are two that will not necessarily make things congruent. And if you're trying to memorize these, and I would recommend that, these are probably the easier side to memorize, is just remember the ones that don't make it congruent. Angle, angle, angle will make two similar triangles. But unless the sides are also congruent, you are not necessarily going to have a congruent triangle. Side-side angle, a funny way to remember this is ASS, also gives two possibilities where one would be congruent, but the other possibility is not. So we can't say that by that definition, it would be congruent. So here's a sample of a proof. You'll see we're given some information about triangles FGH and JKL, and we're asked to prove that one of the sides that is not labeled is congruent to its corresponding side on the other triangle. When I say corresponding, I mean the side that would line up if we were to drag one triangle on top of the other. And you'll see that we have an actual abbreviation that you're going to use in proofs that you see here, CPCTC. So based on this, we have an angle, and then another angle, and then a side. So angle, angle, side is one of the postulates that allows us to say that these are congruent. And so our second statement is just that by angle, angle, side, they are congruent. And you don't need to be any more elaborate than that. AAS, we know that it means angle, angle, side, or at least I do. The last statement is what we're meant to prove. And because we've shown that these are congruent triangles, what you're saying is that these are corresponding parts of the congruent triangles. Corresponding parts of congruent triangles are congruent. And that makes sense because the pieces are all congruent to each other as they are congruent figures. Now here's a question for you. Which of these triangles are congruent? I'll give you a hint. 2 of the triangles are congruent. Did you see that we have angle, side, angle on triangle JKL and angle, side, angle on triangle OMN, the 2 left triangles? But if you look over to the right, they're not in the same order. So even though the same information is given, we have angle, angle, side. And that is not the same information. The information has to be in the same order to show that the 2 triangles are congruent. Here we're given a side and an angle. What additional information would you need in order for this to be 2 congruent triangles? Well, we could look at our list, and there are a few different possibilities. You could have angle, angle, side. You could have, say, side, angle, side. What's the one that you're not allowed to use when we're given a side and an angle? Angle, side, side is not an acceptable option. So make sure that as you list, that you're being careful not to use angle, side, side. Thank you very much. See you in class.